Let's try these two examples out that use the complex number system, the imaginary unit, and simplification. So the first one is a multiplication problem, -2 plus 5i times 1 plus 3i. For that one, let's employ a distributive property, or sometimes referred to as a foiling technique, where I'm going to multiply -2 times 1, which is -2, and then we're going to do -2 times 3i, which is minus 6i. Then we'll do a 5i times a 1, which is a plus 5i. And then we'll do 5i times 3i, which is 15i squared. Okay, I squared, remember, is the imaginary unit squared, so that is the number -1. So after that simplification, we'll get -2 minus 6i plus 5i. And then the -1 times 15 is going to make that one opposite down to minus 15. So now, if we collect like terms, -2 minus 15 is -17, and -6i plus 5i is minus a single I. So in standard form, there's the final answer. So now let's try example number 2, which is a squaring problem. So if we square this problem, recall the square of a binomial formula. We can remember that this is 4 squared plus 2 times 4 times I plus I squared. So in other words, we have a 16. 2 times 4 is 8, so we have an 8i, and then we have an I squared. Now, just as before, remember that I squared is the same as -1. So after we perform the imaginary number simplification, we get 16 plus 8i minus 1, and of course 16 minus 1 are like terms, they're both real numbers, so we combine those to get 15 plus 8i. And that's our final answer.